All right, so here we have a ladder that's 15 feet long and it leans against the tall stone wall. The bottom of the ladder slides away from the building at a rate of 3 feet per second. How quickly is the ladder sliding down the wall when the top of the ladder is 6 feet from the ground? And then what at speed is the top of the ladder moving when it hits the ground? Okay, so we have some ladder leaning against the wall, and probably the wall goes up even higher, but it doesn't say one way or the other. But we know that that's 15 feet. Well, let's call that height, and let's call that, X. I don't know what you would want else to call it, but we'll call it X. And so, what do we know about this? Well, this is a right triangle because this is a right triangle, a right angle at this point here. So let's start writing down our steps. Okay, so step one. Well, our dependent are going to be what? Well, we have X and an H. And so, X and H, and they're both in feet. Okay. Now, our independent, okay, well, that's in what? That's going to be a time again. And now we're doing feet per second. And so let's do time as in seconds. Okay. And so that's going to be that. We know that the rate going this direction is 3 feet per second. Okay, so we know that it's sliding that way. So we're going that way. And so this is coming down, it's going out that way. And so that's kind of a pictorial and kind of description of what we're doing here. So step two, this time we actually have to write our own equation. Well, do we know anything that would relate all those pieces? Well, if we use the Pythagorean theorem, we could say 15 squared is equal to x squared plus h squared. Okay. Now, that's our equation we're going to use, and it relates both of those. Now, usually what happens is one's on one side, one's on the other side, and we can do that. So if we wanted to, we could rewrite this, maybe we would say I don't know, x squared is equal to 15 squared minus h squared. Now we see it as there's something on each side, and we have it in terms of the other variable, which is nice. And otherwise, what we'd have to do is we'd have to take the derivative of this, and then we'd have to take a derivative with respect to x here, and the derivative of with respect to h here, and doing both of them on the same side might be confusing. So if we put one on one side, one on the other side, that might help us kind of do it all together. So now step three is take that derivative of this. And so we're going to have d dt of x squared is equal to d dt of, now we have 15 squared minus h squared. And so this is going to give us 2x dx dt equals, now this is, well, when we take a derivative of a constant, that goes away. And so then we have a minus 2h, and then it's going to be dh dt. Okay. Now, what do we want to do? How quickly is the ladder sliding down the wall? So we want the how quick it's going here. So we want dh dt. Okay. So we need to solve what we did in step three for dh dt. So what we're going to do is we're going to say, okay, well, basically how to do that? Well, we're going to divide by negative 2h. We're going to divide that by negative 2h. And so for step four, we have dh dt is equal to, well, when we divide 2 by 2, that's just 1. So it's going to be a negative x over h dx dt. So that's going to be our equation we're going to use, and we're solving for the rate here. Okay, so what do we have? Well, in our problem, it says now h is 6. Okay, so we have h is equal to 6 feet. We know the speed, the dx dt, that's going to be 3 feet per second. And so what else do we know? And do we know anything else? Well, we can get x, can't we? Because if we know h, and we know 15, we can get x. So how do we do that? Well, we just plug it in. And so we say, okay, 15 squared is equal to 6 squared plus x squared. So subtract 6 squared. Oops, minus 6 squared. And so x is squared equals 15 squared minus 6 squared. And so x is equal to plus or minus, well, we only need the plus distance, the square root of 15 squared minus 6 squared. And if we plug that into our calculator, 15 squared minus 6 squared is equal to 189. So that's equal to the square root of 189. So x equals the square root of 189. So now we know everything. So we can find dh dt. Well, that's going to be a minus the square root of 189 over h, which we said was 6, times our change here, which is 3 feet per second. Okay, so if we just plug in that, we have the square root of 189, and then that's going to be divided by 2, basically, it looks like. Okay, and so when we do that division, we get a negative 6.8738. So maybe 684. Oh, wait. 6874. Yeah, that'll be good enough. And what is it going to be? It's going to be feet per second that it's going down. Okay. And since it's going down, what can we say? Well, we can say the ladder is sliding down 6.874 feet per second. So we wouldn't want to put a negative here because if we're sliding down a negative 6.874, that would be meaning it's going up. And so that negative indicates it's going down. And so we can just say it's sliding down that many feet per second. Okay, so that would be our first part. So that would be part A. And so that's going to be, I guess if we write it in sentence format, we could say that, or if we wanted it in just the number right off of the equation, that's what it would be. All right, now at what speed is the top of the ladder moving when it hits the ground? So when it hits the ground, what do we know? Well, that means h is going to be 0 when it hits the ground. And so when we do that, what happens here? Well, where it means we're dividing by 0, which we can't do. And so what we're going to have to do is it looks like we're going to have to say, okay, well, dh dt is equal to our negative x over h of dx dt. And h, we're getting really close to 0. And so what we're going to do is let's take our limit of dh dt as h goes to 0 is equal to our limit as h goes to 0 of negative x over h dx dt. And so, our x, that's going to be changing depending on, h. It's going to all affect that, Pythagorean theorem there. And so what's going to happen is, that's going to hit a number of 15 because that's going to be how long it is when this is 0. And now when that goes to 0, divide that, basically we're going to have infinity. So as h goes to 0, the negative x over h goes to infinity. And so it's going down, and it's at that point where it hits, it's at infinity. But that's kind of not really possible because you have some interference with friction, things like that. And so while ideally that's where it's going to be hitting, we know that friction, other things along the wall and on the ground are going to cause it to not actually hit that speed. And so mathematically, it's not going to be the same as what it's actually going to be in real life. So that's kind of how B is going. It's going to be approaching infinity, but in reality, it can't actually hit infinity. So that's what I would do for part B. All right, so let's do another one.